This section is on probability notes, and we're going to look at coin tossing and rolling a dice, one die. So for this these set of notes and for this worksheet, what we're going to do is we're going to look at two different virtual online tools. One is a coin tossing tool, which we're going to look at first, and then we will look at the dice rolling after. So it's a very simple program. You have the number of coins, the first option, number of repetitions, which is the number of times you toss the coin, and then the probability of getting tails, which we're going to leave at 50%. Because 50% tails, 50% heads is what's called a fair coin. So for this first experiment, we're going to just do 10 tosses, not 100, 10. Okay, so we'll leave that at 10. We'll go back to the worksheet here, or the notes. And for the first one, for the experiment, you are actually going to toss a coin. Toss a coin, you flip it. What does it land on? And then you type in or you write in whatever it happens to be. Okay, and you keep on doing that. You do it 10 times. So you flip the coin. Heads is H, tails is T, and you write that in. The virtual experiment is what you do when you're doing this one. You just type in the number of repetitions that you're going to do. It will ask you for a bunch. You click on toss, and it will actually spit out the data below. So it'll tell you what the results were, and it will spit out this table, which we'll look at in the next example. But for this one, you're just going to write these results, tail, tail, head, and so on, in here. So you have tail, tail, heads, and just write those down. So you can kind of compare what you got, your experiment, with the virtual dice. The next one we're going to look at is 100 or 100 trials. And to do this experiment with 100 coin tosses would take a very long time. But this program can do it very, very quickly. So if I just add another 0, I know that's going to be 100 times. I'm going to toss it. It actually spits out all the data. You're not going to have to write all those letters down. Don't worry. All you need to write down is the outcome. You don't need to write down the outcome, but you'll be the number of times it happens, which will be shown to you by the top, the numerator. The frequency, which is the entire fraction. Experiment, which is this number here. And the theoretical, which is that one over there. So in this case, for the outcome of heads, this 1 in front of the H represents that's the heads. The 1 in front of the T, that whole line represents the number of tails. So the number of heads first was 52, which was 52 out of 100, which ended up being 52%. Whoops. And the theoretical probability, of course, is 50% because we're assuming that this is a fair, what's called a fair die or fair coin. So the next one, of course, has to be 48 because we only did this 100 times and they have to add up to 100. So I get 48. I mean, we can check too, right? 48 out of 100, which is 48% probability. And the theoretical probability, of course, remains at 50% because this is a fair coin. So what you would do when you're asked for more trials is you would be asked to look at this column, and you'd be asked to compare. How do they compare? Are you noticing anything happening as we increase the number of trials, as we increase the throwing of the coin, tossing the coin? Okay, so that's how you fill in that chart. The last thing I want to look at for coin tossing is a tree diagram. And a tree diagram, you start off with what you're doing. I'm tossing a coin. Okay, so I'm starting, this represents my coin. And then as you go through the tree, you'll have to write in what can happen, right? The results. So the first result could be a tail. Second result could be a head. That's the first coin toss. The second coin toss, so that's down here, over here, is what could happen the second time you toss it. So after I got a tails and I toss it again, I could either get again a tails or a heads. If I got a heads, same thing. I could either get another tails or another heads. So with tree diagrams, you basically map out all the different possibilities you could have. So for these ones, if I kept going, I would have 2 more for each, because I would toss it again and again for each coin toss, right? This is the number, and then you would follow one of these paths. Would be the path that you would choose, or you would kind of you could have. You could have a tail and a tail, or you could have a tail and heads, or you could have a heads and a tail, or you could have a heads and a heads, and so on and so on. That's how tree diagrams work, and that's how they're kind of nice to map out all your possibilities. Okay, Next example is dice rolling. So again, you're going to actually do the experiment. You're going to roll a dice and you're going to say, oh, I got a 1, or I got a 2, or I got a 3, or so on, right? Whatever you happen to roll. And virtually, we'll go back to our little thing here, back to the course. This time we're going to look at the virtual dice roll. That's what we're going to use for this one. I'm going to type in 10 because we're going to do it 10 times. I'm going to roll it. This one doesn't spit out all the numbers that it gets, but it shows them down here. It shows the frequency. So for a 1 on the dice, I got that once. So we could go up here and I could fill in a 1. We didn't get any 2s, 0. 3s, we got 2 of them. So I'll put in 2 3s, and so on. I would fill in this whole chart for all the 10 different numbers that you get. Okay, and you could compare your experiment, what you got, with the virtual experiment online. Just like the coin toss, we're going to do this one as well 100 times. So I go back to here, I add another 0 to make it 100. I roll it, and then it spits out all this data here. And I'm going to fill this in the chart as well. So for number 1, I got 22 out of 100. So that means there was 22 ones that I got. So for ones, I got 22. The frequency was 22 out of 100. Probability for my experiment was 22%. And theoretical probability is 1/6, because 1 out of 6 of all the numbers on the dice is a 1. And that is roughly 16.6 repeating percent. So this brings into play all of the things we've been doing with fractions, converting to decimals, converting to percents as well. And the theoretical probability will be the same for all of these. All of these will have 1/6 because there's only 1 2, 1 3, 1 4, and so on the dice, or on one die. Okay, so all of these are going to be rough. They'll be the same. These values will change though. Some of them you might get 0. Some of them you might get 40. Some of them you might get more. Who knows, right? You do the experiment, you write in, you fill in the chart. And again, as you're asked to do more of these, like 100 or 1,000, or even I think I even asked for 1,000,000, you look at this column and this column, the experimental and the probability and the theoretical, and you compare them. Check them out. What's happening as I'm doing more and more trials with these dice, with these coins. Okay, so that's the virtual online tool. And lastly, this question you'll be asked as well, but don't worry about that right now. You will do that on your own. I want you to write 2 examples of independent and 2 dependent events. 2 examples of each. For example, a dependent event could be, say, let's try this. Number of people, this is ridiculous, jumping off a cliff, and the number, don't write this, well, you have to come up with your own, the number of broken limbs. Okay, so if we're looking at this event happening, crazy people jumping off a cliff, there's always that phrase, if your friend would jump off a cliff, would you? And we always say no. And the number of broken limbs. So those 2 events are fairly dependent on one another. If you're going to jump off a cliff or jump from a high place or fall, then you might get some broken limbs. Things like that, things that are directly connected with each other. The amount of chips you eat and I don't know why I use that, chips you eat and your cholesterol level, right? Those 2 events might be linked somehow. Or more kind of grounded, if you took a card out of a deck and looked at it, you have a 1 out of 52 chance of picking a correct card. Like you pick a card out, you say, I think it's a 3 of hearts or something. If you put that card back in the deck, or even if you keep it and then go to, you put it back in the deck, grab another card, those are dependent events because the next card you pick is dependent upon the first card you pick. Sorry, if you don't replace it, if you take it out. Independent events are like this experiment we just did. So coin toss. Coin toss and dice roll. So if you toss a coin, you get a result. You roll a dice, you get a result. Those are completely independent of each other. One has no bearing on the other. Unless you could change this experiment to have the coin toss and the dice roll at the same time and throw them in a little box. And if they interact with one another, then of course they would be dependent events, because they would, if one hits the other, it would change the result. But that's what I mean. Come up with 2 examples on your own. Just think about it for dependent, and 2 examples for independent events, things that can happen. Anyways, that's that lesson. I hope that helps. Please get the worksheet as well and fill it out and complete it.